Hello everyone, my name is Li Xin from the University of Syahrin in Malaysia, currently studying IUPC in Year 1. I am presenting for the IUPC2022 under the topic of Machines and Instrumentation, under the guidance of lecturer Dr. Ahmad, Syahrin, Idris. The title of our poster is The Performance Characteristics of DC Motors for Electric Public Vehicles. In this presentation, I will be going through the following content: research background, objectives, problem statement, literature review, research design, results and discussion, conclusion, and finally, future work. To start, this title was chosen in respect to the increasing growth of the electric vehicle market, EV for short. The graph on the right shows the growth of energy-efficient vehicles from 2014 to 2018. And it is expected to grow even more with the expansion of Malaysia's EV roadmap under the National Automotive Policy of 2020. We also see EVs proliferating in the public transport sector. A very recent example will be Rapid KL introducing trials for EV buses, which is in line with the 12th Malaysian Plan targeting carbon emission reduction by 2050. However, there are problems associated with the electric public vehicles, mainly, firstly, the heavy weight of buses. Secondly, high running costs, including charging and maintenance of the buses. And lastly, the requirement to travel for long distance drives. The first objective of our research is to measure the performance characteristics of series DC motor and shunt DC motor. And secondly, to determine the best DC motor configuration for electric public vehicles. In terms of electric motors, these can be categorized under DC, direct current motors, and AC, alternative current motors. DC motors can be further categorized into brushed DC motor, brushless DC motor, and stepper. And AC motors can be categorized into induction motor and synchronous motor. A comparison of AC motors and DC motors shows different characteristics, but both have been used in the current EV market. DC motors, however, have the advantage of being simpler to implement because of the DC battery-powered source, thus making it smaller in size and weight and more affordable. For our research, we are only concentrating on DC motors. DC motors can be further categorized into series DC motor or shunt DC motor. The configurations are shown below. This can be implemented as a brushed or brushless DC motor. For our research, we will concentrate on the brushed DC motor due to the simpler design and its availability. This is how the experiment was conducted using DC motor experimental setup. We make use of the multimeter to measure the voltage and current characteristic of the motor, tachometer to measure the motor speed, and dynamometer to measure the motor torque. This is the theory that relates the torque to the control parameters as given in the formula on the left, where T is equal to torque, LF is the inductance of the magnetic coils, IF is the field current, IA is the armature current, VA is the armature voltage, omega is the motor speed, and RA is the resistance in the armature. The graph on the top right shows the torque versus armature current for both shunt and series DC motor. There is minimal difference between the two, showing the negligible difference between them. The main difference that we see, however, is between the torque against the speed characteristic of the shunt and series DC motor. We see the speed characteristic of the shunt DC motor is limited compared to the series, which has a much wider range. We also see that the torque for series DC motor can go to a much higher value at a much lower speed. Therefore, due to the heavy weight of the electric public vehicle, this is the range that is the most preferable. Therefore, shunt DC motor are more suitable for belt-driven applications due to the limited speed range. Series DC motor, on the other hand, are more suitable for heavy EV public vehicles due to the higher torque at low speed. In order to support the heavy weight of a vehicle's body and its passengers, a high starting torque at low rotations per minute (RPM) is required. Speed regulation is also a prime concern for mobility purposes. This concludes that the series DC motor would be the advantageous choice for use in electric public vehicles such as a bus. For our future work, we plan to apply our learnings towards DC brushless motors, which has the advantage of less maintenance, higher efficiency, and it is also quieter. We also aim to implement regenerative braking in order to aid in longer distance travel. Thank you very much for your attention, and we hope that our research further benefits the community.